Conventional manufacturing typically requires dedicated equipment for each type of product. In addition to bespoke hardware, control of the manufacturing process is often centralized, with customized software specific to each process. Although suitable for continuous manufacture of a single product, this approach is inflexible, making it difficult or even impossible to quickly alter the production process. A more dynamic approach will be achieved by implementing a new generation of smart production systems, capable of both responding to change as well as performing tasks more efficiently. To secure long-term success, MASMEC is contributing to the development of the Open Manufacturing Operating System, OpenMOS, a state-of-the-art open-source platform for intelligent automation. The OpenMOS project has two key goals: a reduction in the time it takes for a system to be reconfigured for a new production scenario, efficiency improvement within an existing assembly sequence. To test and verify these concepts, MASMEC has created an industry-ready demonstrator, representative of a production line in the automotive industry, valid to Technology Readiness Level TRL6. The concept is a leak test scenario, in which a pressurized container is tested for leakage and repaired if necessary. The purpose of this demonstrator is to prove the overall architecture's functionality, measure key performance indicators of response time and cycle time in comparison to a conventional system. This demonstrator consists of a closed-loop conveyor which moves a product between 6 connected workstations using pallets. Station 1 is the point at which products are manually inserted into the line by a worker. Stations 2 and 3 are twin stations which use pressurized air to test each product for leaks. Station 4 is used to manually unload products which have passed the leak test. Station 5 uses an industrial robot to reseal the product with glue if it fails the leak test. As this is only a demonstration, the gluing activity itself is only simulated. Station 6 is responsible for drying the glue using a robotic device. Product flow within the demonstrator is controlled by 2 junctions and a bypass. Junction 1 splits the flow of incoming products between leak test stations 2 and 3 to balance the workload at each station. Junction 2 directs products which pass the leak test to the manual unloading station, while directing failed products to the gluing station for repair. Once the testing process for each product is restarted by bypassing the manual loading station, closing the conveyor loop. If the product fails more than a predefined number of times, it is considered as bad and will be sent to the manual unloading station for removal. Each station is controlled by a PLC, which connects to the rest of the OpenMOS system through an interpreter device known as device adapter. This allows the OpenMOS technology to be integrated and tested in an industrial relevant environment. As with conventional manufacturing system, OpenMOS uses a manufacturing service bus (MSB) architecture to allow data to be passed throughout the system. However, unlike inflexible approaches based on pre-configuration, the OpenMOS framework allows to equipment to be easily added or removed from the demonstrator. Each device adapter includes discovery services, which declare the presence of the device to the MSB to achieve the desired reduction in reconfiguration time. Furthermore, each device is capable of communicating with any other, allowing for both seamless vertical and horizontal communication. The additional inclusion of a cloud level is intended to increase efficiency through process optimization and a reduction in energy consumption. By using the plug-and-play capabilities in conjunction with process optimization, production systems can be quickly reconfigured in order to remain optimal. As the capabilities of any newly added service would be unknown to the MSB, each device adapter communicates the added capabilities in a format known as skills. To ensure any functionality can be expressed, a common and standardized semantic model based on the Automation ML platform is used to describe and configure those skills. By creating an MSB device adapter for a web server, the MASMEC demonstrator has been equipped with a web page, which allows a user to oversee current production statistics or start a production batch, even from mobile devices such as a smartphone or tablet. The MASMEC demonstrator has met its main objective. In addition, by measuring the key performance indicators of response time and cycle time, it has demonstrated that the OpenMOS framework is either on par or exceeds the performance of a standard PLC architecture in these areas. Moreover, when considering the additional benefits of plug and produce and auto-optimization, it can be concluded that the OpenMOS platform can considerably increase the overall performance of a production line, as well as enabling the rapid reconfigurability, which will be a necessity to remain competitive in the future.